extending algorithm W to handle algebraic data types and pattern matching that is available in Haskell. So suppose we extend the expression E to cater for the data constructor and as well as the pattern matching. And for pattern P, we have like a constructor pattern, variable pattern, and constant pattern. And we assume that the data constructor that introduced by any data type declaration of form like data T, which is a type constructor, alpha, which is the type variable. For now, we just, for simplicity, just keep one. And then we have a bunch of data constructor, different clauses. And we basically argue that this form of declaration would allow us to automatically record the following type binding in the gamma init. Basically, for all the k1 to kn, we will have for all alpha its individual type of its parameter, and finally return t of alpha that is in the gamma init all the way to kn, which handle the case expression. So what it says that under the type environment gamma, if we want to infer the expression case E of the bunch of a set of pattern clauses, and what we can do is that first we need to infer the type of the conditional expressions, which is E, which has some type T0 and with the type substitution size 0, and then we use this T to apply to an auxiliary judgment that takes all the PI patterns, and that would produce a type environment gamma I and some substitution psi I. So this rule, you'll see that in the next slide. Basically, in a nutshell, what it says is that assuming that we know that the input type is T0, and we're going to match the value of this type into all the pattern clauses, and what it does is that it will produce a new type environment gamma I and a substitution psi I for us to enhance the type environment, which we can use it to infer the right hand side of the pattern clause EI, which will give us a TI and psi prime I for all the I in 1 to n. So now, given that the alpha 1 is a fresh variable, we're going to need that to be the return type of the case expressions. So we're going to apply the MGU of this alpha 1 to all the Ti that we infer from this step. Okay, for now, let's assume that we can overload the MGU function that takes in multiple parameter, which means that, well, we are finding the most general unifier among all the type here. And let's say this will produce a substitution psi n plus 1. So the whole expression will have the type applying psi n plus 1 to alpha 1, and then the substitution that we need to return will be composing psi 0 all the way to psi n plus 1. The auxiliary type judgment for the pattern. Recall that in a previous slide we need to have this auxiliary rule or step that given the input type and given a pattern, we like to infer a new type environment and a type substitution. So for example, in case of constant pattern, this is straightforward. We just return the empty type environment. There's a typo here. This is attribute empty set, which is curly bracket instead of square bracket, and we produce a MGU substitution between the int and the t and the psi. And for the variable pattern, we simply just produce the gamma. The new gamma will be binding t to x, and we return a empty substitution. For the data constructor pattern, we assume that the input type must be some algebraic type of form t applied to a list of actual type argument t bar, and we're going to take a look at all the individual pattern p1 to pn, and we know that from the type environment gamma init, we would have the k of type t1 all the way to tn that return us ti prime that is inferable from the type environment. Okay, because we say that all the data constructor have already been recorded in the type environment. So we just fire a auxiliary steps here, and this is to type check that under the gamma init, the K will have this type. And then we just need to perform a MGU amongst the T bar and the T applied to T bar and T applied to T prime bar, and that would give us the psi, which is the MGU. And then using this psi, we apply to all the TI and to infer all the sub patterns, okay, PI, where I from 1 to n, that produce all these sub type environment gamma I and all the site I individually for each of these P, because the type information have been propagated to all these sub patterns itself. And finally, we will union all this gamma from 1 to n together, and we also chain up all the psi from 1 to n plus our psi that produced from the top level. That will be the updated type substitutions and also the type environment.